So let me share just quickly how I use UMathX in my teacher education program. So here's a main screen for UMathX. There are over 3,000 lessons and 1,500 test questions. It's divided into, this is the launcher lesson, this is the entire curriculum, and content menu is a universal global curriculum of all the subject areas in math. So if you go into universal curriculum, it's divided into all the different subject areas. So it's a database of an entire universal curriculum. If you want it to be more specific, and UMathX is being used in different regions, let's go to Ontario, it takes the same database from the content menu and it divides it into the different grade levels. So what might be taught at grade 3 in Ontario might be taught at grade 1 or grade 2 in Florida. So this is our curriculum, taking an entire universal curriculum, divided up and organized into how we teach math in Ontario based on our curriculum. So let's say, for example, I'm going to go to grade 3, look at number sets and numeration, look at operational sense and adding and subtracting 3-digit numbers. I'm going to do it with regrouping. And UMathX, one of the things that it does, it shows you the virtual manipulatives. So as I use this as a way of reinforcing, having my students use the actual manipulatives in class, and so they can go off and practice at night. So afterwards in the evenings and practice on their own. So I'm going to build the number 136. It's one group of 100, 3 10s and 6 1s. I'm taking those from the pile, and you can see the corresponding symbols to the virtual manipulatives. That's 133, 134, 135, 136. So it moves over. So you've got the words, you've got the symbols, and you've got the virtual manipulatives. So I'm adding 136 to 199. And I'm going to move over one group of 100, 9 groups of 10, and 9 groups of 1. And if the students make a mistake and they try to put too many, it gives them a warning that there are too many 10s. So it's self-checking and foolproof in a sense. So I'm taking all the 9 group of 1s, bringing those over. So I've got 9 group of 1s. So again, takes the words, the written symbols, the numeric symbols, and then corresponds to the virtual manipulatives. Now I'm going to add them. So I click the add button. I'm adding the 1s column first. So the total number of 1s, I can count them 5, 10, 14, 15. There are 15 1s. If I made a mistake and I typed 14, what UMathX will do is count off to show me that I've made a mistake, and to recheck that it's not 14, 14, 15. So I correct that and I put 15. And so I have 15 1s now with a symbol, and move it over here. And it's now we want to select how many groups of 10s are possible. So I need to put them in groups of 10s. So, and I don't have to do this in any particular order, but I need to create a group of 10, and we move over to 10. So here's what it does. Now we carry the 10. We do never carry a 1. This is a group of 10 or 110 that we carry. So it shows how that's done. So total number of 10 is 10, 11, 12, 13. The 13 10s. and puts the 13 tens in the tens column. How many possible groups of 100 can we make? And I break those down into hundreds. And I need 10 groups of 10, and moves it over into the tens column. And then we move over our one group of 10. We don't carry a 1, we carry one group of 10 tens. So we carry a 100. And proceed. Now we count the number of hundreds. We have 3 hundreds. And our final answer, so if we had 136 and 199, the answer is 335. And I have to type that in there. And that's right. So it goes on to the next problem. Students can play around that and use that. When we did this in Tanzania, I'm working with a Tanzanian curriculum going back to, we had to go to the content menu and find the area that students had been not being familiar with the curriculum. So what we did was go to the universal curriculum. So here we can search by curriculum area. So in Tanzania, we did number operations. We go to page 2 and adding numbers concretely. And we're going to do it without regrouping this time. So same kind of lesson. This one's probably at a grade 3 level. So I'm going to proceed. So let's make 26. So 2 groups of 10 and 6 ones. And then it's showing the corresponding numbers, so students make the association. So that 26 move the written symbols, again, it's a numeric symbol, the digits, and we're adding 13 and 1 group of 10 and 3 ones. So 1 10, 3 ones, so 13. Now we need to add them together, and in this case, we're not regrouping. So when we add these, I have 9 ones, and it shows a symbol there, and it goes from here to go here. So students can start developing the algorithm and going to just working with symbols. We want them working with virtual manipulatives or the real manipulatives first, then they can go to the symbol. So eventually we work them up to go into just using the symbols, but they have to understand that they're moving actual 10s and 1s over. So we have 9 10s, and so 9 1s and 3 10s. And that's 3 10s, 3 10s. And the answer is, if we add 26 to 13, the answer that we get is 39. And the students have to type that in, and it tells them that, that they're right. So going back to the main menu. So one thing that I like about UMathX, and going back to the main menu, there's a test bank, and you have tests for the different areas where we're using UMathX, Western Canada and Ontario and Florida. So you go into the Ontario test, and there are custom tests in there. You can make up a test, and there are already tests in there. The neat thing about this, and there is that when you set a test for students, is that you can monitor each student to see what areas that they're getting the correct answers in. So there's a whole database for your students when they're working through this for the whole semester. You can graph the results over the year. Kids can have access to see their own graph, and you can look at the whole class and see where the class is improving. So it's an analytical tool for the teacher and also for the kids. And so there are 2 types of access. There's a student access, so the kids go and do the problems, and it walks, and the they walk through it, the UMathX will walk through it, and it can do the testing, and the teacher can monitor their testing. What we're looking for is teacher candidate access, where the teacher candidates can have access as a teacher, so they can give username and passwords to their students. The students can go online and walk through the problems. So you can see what problems the students had. You can see where they areas that they had difficulty. So you can go back and once a student has done a question and they're having difficulty in that area, they can click on sample questions to walk them through it so they can reinforce that. So the teacher candidate will have a way of giving a password and ID to all their students. Students can go online and they can monitor their students and see things graphically and be able to analyze the students. Another thing too, this is the UMathX main website. Just recently, before the new curriculum was announced, that UMathX has started using coding, has introduced coding and robotics. And right after that was introduced, the brand new curriculum came out. So this is brand new, really forward thinking that this is exactly the way that we're going. So UMathX now has coding and robotics way before the ministry curriculum required it. So last thing I want to show you is one of the main issues for me is working with teacher candidates coming in September. Our teacher candidates, their particular PJ, those who dropped math in grade 9 or grade 10, finite math, calculus, and trigonometry, coming into our PJ math program, doing math, to do math for the first time in years. And one of the things I work on in the first month is a growth mindset. So UMathX, they start out with the growth mindset, and then what they call it is this learning pit, a model for working through the growth mindset. So students come in, and I get this a lot, I don't understand, I don't get it, it's too hard, they're nervous, they're ready to quit, and you get them to grapple. And as a constructivist teacher educator, I want students to grapple in a productive struggle. And using the manipulatives, it reinforces the learning, and the manipulatives are foolproof. Get them to build a model with the manipulatives, get them to act it out, get them to draw it, get them to talk through it, get them to write it, and then they come up on the other side when they own it. And so every module, every step of the UMathX program walks through this. So that's just an overview, again, of how I'm using UMathX in my program, and I'm excited about the possibilities of what we can do. I've worked with other programs. I tutored a kid in Florida that was using Alex, and some other programs, and I wasn't impressed with this. What I really like about this, it has the virtual manipulatives. I can walk through some conceptual understanding before I get students understanding procedure. So the conceptual framework is very, very important to me in my program. So that's it. Thank you.